Communities along the freshwater Mississippi River are facing a growing threat from an intrusion of saltwater from the Gulf.
Well, the future of Minnesota's most famous river is in danger. That's according to a new report that ranked the Mississippi among the most endangered in the country.
A sudden surge of seismic data from beneath the Mississippi River Delta has triggered urgent alarms in the geological community, as an unusual and deep crustal movement has been detected, prompting scientists to issue a rare and serious red alert. This deep subsurface shift is not only rare in its magnitude and location, but also deeply unsettling due to its implications for both the immediate region and potentially vast portions of the United States. As sensors scattered across the Gulf Coast began to pick up strange activity over a 48-hour period, the patterns quickly escalated from routine tremors to signs of a profound tectonic disturbance, one that experts believe could mark a major geological inflection point for the region. Before we start, smash the like and subscribe buttons for more updates. The Mississippi River Delta, known more for its ecological complexity and slow subsidence due to sediment compaction, is not traditionally considered a hotspot for deep tectonic agitation. Most seismic activity in the U.S. is commonly associated with areas like the Pacific Northwest, California, or along the new Madrid Seismic Zone. However, this newly observed crustal shift lies deeper than previously studied fault systems in the region, suggesting that something much more fundamental is at work, something rooted in the Earth's lower crust or even upper mantle. Geologists and seismologists reviewing data from deep Earth monitoring arrays have observed that the movement doesn't appear to be a single fault rupture or a cluster of aftershocks. Instead, the readings indicate a widespread, sustained shift in the geological basement layer, something that can happen when vast sections of the Earth's lithosphere begin to deform or buckle. This is especially concerning under the Mississippi River Delta, where centuries of sediment buildup, oil and gas extraction, and hydrogeological change have already strained the equilibrium of the landscape. What was once thought to be a relatively stable sedimentary basin is now revealing signs of concealed tension brewing below the surface. One of the most perplexing aspects of this event is the nature of the movement itself. Unlike a classic earthquake, where sudden slippage along a fault causes a sharp release of energy, this phenomenon has exhibited characteristics of what geophysicists call slow slip events. Movements that occur over days or weeks, releasing enormous tectonic pressure with little or no surface shaking. Such events have historically been linked to major tectonic transitions and are often seen as precursors to larger, more violent quakes. The slow slip beneath the delta, however, is unusually deep, suggesting it may be altering the stress regime of a vast region from below. As data streamed in from stations along Louisiana, Mississippi, and extending into the Gulf of Mexico, one clear fact emerged. This was not a localized tremor or a shallow crust anomaly. Instead, the deformation zone appeared to stretch across a wide arc beneath the delta, with GPS sensors recording subtle changes in ground elevation and lateral motion across hundreds of kilometers. These surface signs, while barely perceptible to humans, match known signatures of deep tectonic warping, where energy transfers upwards from the deep crust and creates ripple effects across the overlying layers. In response to this data, the United States Geological Survey (USGS) initiated a Level 1 geohazard review, deploying additional portable seismic equipment and satellite imaging systems to refine their understanding of the deformation pattern. Almost immediately, the seriousness of the situation became apparent. Something was stirring deep beneath one of the most hydrologically and geologically sensitive regions in North America. The movement was happening at a depth and scale that made simple fault mechanics inadequate to explain it. It appeared to involve ductile flow, plastic-like deformation, within the Earth's lower crust, a process more typical of plate boundary zones than stable continental interiors. The implications of this are staggering. For one, it raises the question of whether previously unknown tectonic forces are beginning to act upon the interior of the North American plate. While the area surrounding the Mississippi River Delta is far from any active plate boundary, there have long been hints that ancient rift systems and buried fault zones still lie dormant beneath the surface. The new Madrid Fault Zone to the north, for example, produced a series of catastrophic earthquakes in the early 1800s, despite its location in the middle of the continent. This latest movement suggests that the entire interior tectonic framework may be under reassessment, and that the delta might sit atop a far more dynamic system than previously imagined. Hydrologically, the Mississippi River Delta is already under immense stress. With rising sea levels, intense subsidence, and decades of industrial development, the region is losing ground at an alarming pace. But if the crust beneath begins to deform on a large scale, it could lead to sudden changes in elevation, disrupt sediment transport, and alter the balance of water flow across thousands of square miles. Wetlands could shift, levees could crack, and the underlying support for cities like New Orleans could change in unpredictable ways. The region, already delicately poised between land and sea, would become even more vulnerable to both geological and climatic hazards. Another concern lies in the oil and gas infrastructure that blankets the Gulf Coast and the Delta. Pipelines, refineries, and offshore platforms all rely on stable subsurface conditions. A reconfiguration of the deep crust could increase the risk of subsurface blowouts, pipeline failures, and induced seismicity, especially in areas where fracking or salt dome storage operations are active. Already, energy companies are beginning to review their seismic hazard models and conducting emergency inspections of buried assets, fearing that the stress redistribution might trigger shallow faults or increase pressure in vulnerable zones. Beyond the immediate area, the effects of this deep crustal movement could ripple outward. Tectonic activity doesn't exist in isolation. It affects stress regimes across broad regions. Geologists are now modeling whether the strain being released beneath the delta could propagate northward toward the new Madrid Seismic Zone or westward into the complex fault networks underlying Texas and Oklahoma. If so, the Mississippi event could be a harbinger of increased seismic risk across a huge swath of the central United States, many parts of which are not prepared for large earthquakes. The rare issuance of a red alert underscores the gravity of the situation. This level of warning is typically reserved for events that carry imminent geological risks or represent the onset of a potentially transformative episode in Earth dynamics. It means that monitoring agencies have observed enough data to confirm a significant anomaly, one that cannot be dismissed as background noise or typical seismic fluctuations. For a region with millions of people living on or near its shifting ground, this red alert is more than a warning. It is a call to reimagine how the landscape might change and how quickly it could happen. Historically, the Mississippi River Delta has been shaped by slow processes: the accumulation of sediment from upriver, the quiet sinking of marshland under its own weight, and the gentle rise of the Gulf's salty tides. But this event suggests that not all changes here are slow or gentle. Sometimes the Earth's deep interior shifts with little warning, flexing forces built up over eons and unleashing changes that ripple to the surface in both dramatic and subtle ways. The very foundation of the delta, the rock beneath the mud, beneath the silt, beneath the water, may be entering a phase of dynamic reorganization, one that could last months, years, or decades. What geologists now face is an enormous investigative challenge, determining whether this deep crustal movement is a one-time anomaly, a periodic tectonic pulse, or the beginning of a larger structural collapse or adjustment. To do this, they are tapping every tool at their disposal, from interferometric satellite radar to borehole strain meters and magnetic flux sensors. Multinational research institutions are collaborating, sharing data and hypotheses, and reevaluating long-held models of subsurface structure in the Gulf Coast region. The idea that a quiet basin could host such profound subterranean drama is forcing a shift in perception, both scientific and public. The Mississippi River Delta has long been described as a place of confluence, of land and water, of river and sea, of culture and ecology, but now it appears to be the site of a much deeper confluence, where tectonic forces long thought dormant may be converging beneath the surface, asserting themselves in ways that could redefine the geography and geology of the region. The red alert is not merely about what has already happened, it's about the potential for future transformation, about forces still gathering in the dark recesses of the Earth, waiting to manifest in ways not yet fully understood. Such deep Earth phenomena often unfold without regard for human timelines. They operate on scales of kilometers and epochs, indifferent to cities, industries, or levees. Yet when they reach the surface, when the balance is tipped just enough, the consequences are immediate and unmistakable. The deep crust movement, now recorded beneath the Mississippi River Delta, could be the first chapter in a much larger story, one in which land shifts not through slow erosion, but through tectonic surprise. In a region where the ground has already been sinking due to natural compaction and anthropogenic influences, this newly emerging tectonic stress introduces a third and much more unpredictable dimension to land movement. Vertical uplift or further subsidence driven by deep fault block motion could radically alter topography, drainage paths, and flood vulnerability. If certain areas are being lifted while others sag, the entire hydraulic logic of the delta could shift, potentially overwhelming existing flood defenses and storm surge barriers that were designed with older elevation baselines in mind. Long-term simulations are now being run to project what even a few millimeters of vertical change per year could mean over a decade. The outcomes are startling. Subtle crustal uplift in one segment of the basin could push water toward urban centers, while sinking in another could create new swamp zones or resurrect long-buried channels of the river. Infrastructure that sits on the assumption of geologic stability, from highways and rail lines to sewage systems and aquifers, would suddenly become obsolete, prone to failure, or dangerously misaligned. This movement, although quiet and hidden at depth, has fundamentally disturbed the sense of geologic peace that many believed characterized the Delta's underworld. It has reframed the conversation about what forces are active beneath the heart of America's largest river system. It calls into question old models that depicted the Gulf Coast as merely subsiding, reminding us instead that tectonic evolution doesn't stop. It only sleeps. And when it stirs, even in the deepest roots of the Earth's crust, the consequences can ripple to the surface with profound and lasting effects. In the wake of the Red Alert Declaration, a different kind of energy has begun pulsing through the scientific world, one not of panic, but of mobilization. The movement beneath the Mississippi River Delta has turned into a focal point for geologists, geophysicists, and tectonic modelers across the globe, prompting a wave of investigative efforts to understand the anomaly in granular detail. This is no longer about identifying a localized phenomenon, it's about deciphering a potential gateway into deeper tectonic processes that could redefine North America's interior stability. At the heart of this investigation lies a powerful and unresolved question. What exactly is driving the crustal displacement? The current data points to complex interactions between ancient fault networks and thermal anomalies rising from the asthenosphere. The Mississippi embayment sits atop deeply buried remnants of failed rift systems, such as the Reelfoot Rift, that date back hundreds of millions of years. These structures, dormant but not extinct, may be reactivating in response to stress transfers occurring far below the lithosphere. The evidence now emerging from seismic tomography and gravitational field data suggests the presence of dense mantle plumes or regions of anomalous heat beneath the delta, an unanticipated source of deep uplift and lateral strain. This revelation has significant implications. Mantle plumes are typically associated with volcanic hotspots and plate breakup events, yet no surface volcanism exists in the Mississippi River Delta today. If heat or buoyancy from below is intruding into the base of the continental lithosphere here, it may mark the inception of long-term geodynamic change, a slow but inexorable deformation of the North American plate interior. In tectonic terms, this would be a subtle signal of continental reactivation, where formerly quiet terrains begin to deform due to thermal and structural weakness deep within their roots. Field teams have been deployed to install dense seismic arrays across the region, especially in southern Louisiana and eastern Mississippi. These portable instruments capture high-frequency microseismicity that large permanent stations might overlook. So far, the data shows scattered clusters of deep microquakes that don't correlate with known fault lines or industrial activity. These microquakes, often imperceptible at the surface, act like sonar pulses. They help map the evolving stress patterns in the rocks below and can indicate zones where brittle failure is beginning to occur under immense pressure. Even more telling, however, is what's happening just above the zone of movement. In several areas where the crust is believed to be deforming, shallow groundwater levels have begun fluctuating in unusual patterns. These hydrological anomalies aren't related to rainfall or human usage, but seem to reflect changes in underground pore pressure, a classic symptom of geomechanical stress altering rock permeability. In simpler terms, the Earth's deep plumbing is being disrupted. Aquifers that once flowed consistently are experiencing pulses of recharge or depletion as crustal blocks subtly shift and contort. Geodetic surveys are reinforcing this picture. Satellite radar interferometry, INSAR and GPS monitoring networks are mapping surface displacements with millimeter-scale precision. These technologies are now revealing an unsettling mosaic of uplift and subsidence zones across the delta, forming a pattern that mirrors the deep crustal anomaly. Unlike the slow and steady settling caused by sediment compaction, these vertical movements are more erratic and spatially disjointed, suggesting that the subsurface is undergoing uneven deformation. In some locations, the ground has risen by nearly a centimeter in just 3 weeks. An eye-opening figure for a region not previously known for tectonic uplift. From an engineering standpoint, this brings enormous concerns. Much of the infrastructure across the delta is constructed on the assumption of gradual, predictable subsidence, not active ground deformation. Roads, pipelines, bridges, levees, and rail corridors are not built to tolerate uneven vertical movements. If deformation continues, even at modest rates, differential settlement could compromise structural integrity, leading to bending, cracking, or outright collapse. Power grids, fiber optic networks, and buried conduits may experience stress they were never designed to endure. More critically, these shifts could threaten one of the most vital components of the U.S. agricultural economy, the navigation and shipping systems of the Mississippi River. The delta marks the terminus of the river's vast inland waterway network, and any significant deformation along its banks or bed could alter channel depth, current speed, and sediment deposition patterns. Shallowing of navigation channels could restrict barge movement, impeding the transport of grain, petroleum, and industrial goods. Locks and dams engineered to precise tolerances may fall out of calibration if their foundations shift, potentially halting traffic altogether in key stretches. Equally at risk are the complex sedimentary systems that sustain the delta's ecological productivity. Mangroves, salt marshes, and freshwater wetlands are all delicately balanced ecosystems that rely on a predictable interface between land and water. If tectonic motion disrupts local elevation gradients, even by just a few inches, entire habitats could flood, dry out, or be pushed inland or seaward. The knock-on effect on fisheries, bird migration routes, and biodiversity could be substantial, potentially triggering secondary ecological collapses. Interestingly, atmospheric scientists are also taking note. Though not directly tied to tectonic processes, deep Earth movements can influence surface gas fluxes. Crustal stress and microfracturing may increase the release of methane, carbon dioxide, or radon from deep reservoirs. Early surveys are already picking up slight increases in soil gas emissions in parts of Plaquemines Parish and near the Atchafalaya Basin. While not yet at hazardous levels, these emissions could serve as tracers, chemical fingerprints of the tectonic stress below. Long-term monitoring could eventually allow scientists to use gas profiles to predict where stress is accumulating in the Earth's crust. For urban planners, the situation is becoming a logistical challenge of extraordinary scope. Many municipalities in the affected region lack the geological expertise or technological resources to assess subsurface deformation risks. Emergency preparedness plans were drawn with hurricanes and floods in mind, not tectonic reshaping. Local governments are scrambling to revise zoning regulations, update building codes, and communicate with the public without inciting unnecessary panic. Yet the reality remains that a geological process of indeterminate duration and strength is now underway, an invisible force shifting the very land beneath their feet. Insurance markets, too, are feeling the tremors. Insurers are suddenly re-evaluating risk profiles in areas once considered geologically stable. Policies for homeowners, utilities, and industrial facilities in affected zones may soon reflect surcharges or exclusions based on newly perceived tectonic vulnerabilities. Earthquake insurance, which was never widely purchased in the Delta region, may become a necessity, not an afterthought. The idea that tectonic risk is now a live concern in southern Louisiana or western Mississippi is upending decades of actuarial assumptions. Meanwhile, climatologists and climate resilience experts are analyzing how the tectonic changes might amplify or compound other environmental pressures. If the land is rising or falling unevenly, existing models for storm surge, sea level rise, and hurricane impact zones will need adjustment. Current resilience strategies, such as coastal restoration projects, barrier island reinforcement, and levee upgrades, are all calibrated to a relatively static landscape. Introduce crustal warping, and those models unravel, potentially rendering entire multi-billion-dollar mitigation efforts obsolete or misdirected. This moment in geological history is forcing a kind of interdisciplinary reckoning. Earth scientists must now collaborate with climatologists, civil engineers, hydrologists, and economists to develop adaptive models that reflect a dynamic Earth system. The Mississippi Delta, once the poster child of slow-motion environmental decline, is suddenly a crucible for rapid, tectonically driven transformation. Researchers from multiple disciplines are racing to assemble a holistic picture of what's unfolding, because without a cohesive understanding, responses will be fragmented and potentially dangerous. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on deep crust movement beneath Mississippi River Delta Red Alert? We want to hear from you. Thank you for watching, and see you next time.